Hello friends, welcome to our YouTube channel Railway Engineering by Subbarao. Today our topic is Railway Curves Part 13. In Railway Curves Part 13, vertical curves in horizontal curves. This Part 13 video has been explained about vertical curves in horizontal curves, what are the adverse effects, concept of grade compensation, necessity of curve compensation, and explained with solved problem. Change of gradient, that is algebraic difference between grades, is greater than or equal to 0.4% fall on horizontal curves is called vertical curve in horizontal curve. Vertical curve in horizontal curve. In horizontal curves, the vertical curves of summit type shall be avoided, especially where LWR is also there. In LWR, the track will tendency to lift up on such summit curves, and due to horizontal curves, there are lateral forces as well as a tendency for offloading of vehicles. Therefore, the stability of the track under load will be adversely affected and track may be susceptible to buckling. Maintaining the vertical curve in horizontal curve will be much more difficult as track geometry changes in three-dimensional. Concept of grade compensation. If the horizontal curve exists along with raising gradient, pulling power of the wheel reduces. Hence, to increase the pulling power, the gradient is reduced to compensate for the loss of tractive effort. This reduction in gradient on a horizontal curve is called grade compensation. Compensation for curve on gradient. Compensation for curvature should be given in all cases where the existing gradient, when added to the curve compensation, exceeds the ruling gradient. The compensation to be allowed should be 70 divided by R percent, that is 0.04% per degree of curvature, where R is the radius of the curvature in meters. Okay friends, we shall move further with the solved problem. This example problem has been picked up at Sulha Anupur in Pandra Road, Anupur, third line, rights project in Bilaspur division. Example problem. A vertical curve is fall on a 2.734 degree horizontal curve. Chain edge at junction of grade is 481.00. Starting falling gradient is 1 in 205.600 and followed by level. Find the steepest gradient on a 2.734 degree curve for a busy line with the ruling gradient of the section is 1 in 150. Given data, degree of the curve 2.734, gradient provided 1 in 205.600, ruling gradient of the section 1 in 150. Welcome back. Vertical curves in horizontal curves. In this curve, this is TPTC1, TPCC1, TPCC2, TPTC2. In this horizontal curve, have the vertical curve. its gradient is, this is level, this is 1 in 205. So this is junction. This is a degree of horizontal curve. From here to here it is transition, from here to here it is circular curve, from here to here it is again transition curve, then straight. In this circular curve, it have the junction of gradient, that is falling gradient and level. Falling gradient is 1 in 205 point something, but I have written only 205 only. This is level. That chain is so and so. What will be the effect on horizontal curve if vertical curve forms? What will happen? We'll see now. We solve this problem. Given data, number 1, degree of curvature 2.734 degree. Next, number 2, gradient provided 1 in 205.600. Say 1 in 205. Next, number 3, ruling gradient of the section. Gradient of the section 1 in 150. We can solve it. Ruling gradient is equal to 0.666%. Next, B, grade compensation curve is equal to 0.04 into 2.734%, 0.109%. Compensated gradient on 2.734 degree curve track is equal to 0.666 minus 0.109%, 0.557%. That is equal to 1 in 179.533. Say 1 in 180 gradient. The steepest gradient to be provided on 2.734 degree curve track is equal to 1 in 180 gradient. Gradient already provided on 2.734 degree curve is equal to 1 in 205. 1 in 205 flatter than 1 in 180 gradient, hence permitted. Dear friends, horizontal curve is 2.734 degree curve. In horizontal curve, there is a exactly in circular portion. It have junction of the grade. The algebraic difference between grades is equal to or more 0.4%. Vertical curve to be provided. The algebraic difference between this is more than 0.4%. So here it will be vertical curve to be provided. This vertical curve, it is fall on the horizontal curve. Already on introductory note we were watched. Now while passing the train on the horizontal curve, it is facing vertical curve. There is a adverse effect, hauling power, then uplift of the track. There is a chances to buckle the track, all these things. To avoid such cases, we are providing the grade compensation for particular curve. So what is the grade compensation? How we can provide? Always remember it. Any section, it have some ruling gradient. 1 in 100, 1 in 150, 1 in 200, 1 in 300, depend upon the sections. But here in this Bilaspur Kathni section. Rule ingredient is 1 in 150. Already here gradient provided in the horizontal curve 1 in 205. The degree of the horizontal curve is 2.734 degree. So to compensate this, we will check this gradient is okay or not. In this 2.734 horizontal curve, ruling gradient is equal to 1 in 150. So that is 1 by 150 into 100. That is equal to 0.666%. Next, grade compensation for 2.734 degree curve is equal to 0.04 into degree of the curvature percent. That is equal to 0.04 into 2.734%, 0.109%. Compensated gradient on 2.734 degree curvature track is equal to ruling gradient minus grade compensation for particular degree. What is the ruling gradient? 0.666 minus grade compensation for 2.734 degree curve, that is 0.109%, that is equal to 0.557%. We convert into the gradient 1 in 179.533, say 1 in 180. So the compensated gradient on 2.734 degree curve track, minimum required 1 in 180. The steepest gradient to be provided on 2.734 degree curve track is equal to 1 in 180. Gradient already provided on 2.734 degree curve is equal to 1 in 205. We can compare the both. Here 1 in 205, here 1 in 180. 1 in 205 is flatter than 1 in 180. Hence it is permitted. Keep it in mind. For example, the steepest gradient to be provided 1 in 180. But whereas here we are provided steeper than 1 in 180. So that is 1 in 160 or 1 in 170 or 1 in 150. Then the gradient to be redesigned in particular curve such a way that gradient should be flatter than, it should be 1 in 180. So this is the concept. If vertical curve fall on horizontal curve. Thank you friends. Thank you for watching this video. If you are interested, kindly like, subscribe, share your friends group and ask them to subscribe such more technical and valuable videos. Thank you very much.